senior physics faculty. So we have started a YouTube live series in which we are going to cover all of the physics topics for 11th and 12th, so that your preparation for IIT and NEET can be very flawless. So I'll be going to cover each and every topic from the beginning to the end. Okay, so we'll have live session each and every day, and I request all of you to please watch the series regularly. So now I'll be teaching you physics, and physics is a very interesting topic. Okay, many students they think that physics is a very difficult subject and they fail to perform well in the subject. There can be many reasons due to this. One of the reasons can be that they don't understand the physics. They just try to mug up the subject. And physics is not about mugging up. It's about feeling. So what does physics means? Physics means nature. Okay. So we can feel nature. Like a ball which fell from a building, right? So we can feel that. So we can solve questions regarding that. Okay, so that let's suppose if I throw a ball from a building, so I can calculate the velocity with which it will hit the ground, the time it will take. So we can feel that. Now, so second part of physics is that physics is about understanding, about feeling, but we require mathematics. Why mathematics? Because maths is the language of physics. If you don't know maths, you can only understand physics, but you cannot apply that. Because if I want to talk, see I am talking with you, okay, my mode of communication is English, right? I can also communicate with you in sign language, right? But some of you will understand, some of you will not. Okay, so the thing is that the thing I'm trying to say is that mathematics is required to understand physics very deeply. So if you are good at maths, physics is very easy for you. So physics and mathematics go hand in hand. So before starting the physics part, I will first cover the basic maths part. What do I mean by basic math parts? All the important topics which we require to understand physics. Okay, so initially 4-5 lectures we will cover some topics which we require so that our learning of physics can be very easy. Okay, so welcome to my first lecture. First lecture is based on functions. Okay, so the topic which I am going to cover in this is, first I'll cover functions and then I'll cover two important functions. Okay, these are subtopics: logarithmic functions and exponential functions. So many of you would have heard about it. So those of you who have not heard about it, let's see, and those of you have already heard about it, pay attention. You may learn something very new. Okay, so let's see. So what is mathematics? Mathematics is the language of physics. Okay, it is a language of physics. The way we communicate in physics is through maths. It becomes easier to describe, understand and apply the physical principles. So it becomes easy for me because let's say I am from India and I only know Hindi. Okay, and somewhere let's suppose I go to America, right, and he only knows English. Now if we meet, we will not be able to communicate, right? So we need one common language. So in physics, that one common language is mathematics. So let's suppose I am in India and someone else is in USA. So if we talk in physics, we will talk in maths. Okay, now, so we can apply the physical principles if one has a good knowledge of mathematics. So he's just trying to say that we need mathematics for physics. So now look in this first diagram. Okay, so now, okay, we know we need maths. Now, let's say in this first example, we can see that this person is cutting a tree with a blade. Now, do you think that he can cut the tree with a blade? Yes, I can. I think that yes, he can. But it will take a very long time and it will be a very tedious task, right? So now, is it advisable to cut a tree with a blade? No, right? So you should use an axe, right? So he is using wrong tool, right? Similarly, look here, this man is invited for an inauguration, and in an inauguration he is using an axe, right? So now it would be very funny, right, if you use an axe to cut a thread in an inauguration. So what should he use? He should use a pair of scissors. So in both the example, what I am trying to say that they are using wrong tool. So in similarly in mathematics, right, we should know that which tool we should use when. Okay, basically which mathematic tool we should use when in physics, so that our calculation or our application of the concept becomes easier. Okay, so what are the basic tools which we require? So now there are many tools which we require. Okay, you have been learning maths from class 1, okay, from your childhood, right? Until now you have learned many things. You have learned about straight line, trigonometry, quadratic functions, okay, multiplication, division, addition. So these all are tools, right? So now in class 11th we will need some more tools to understand physics. So some of the tools are differentiation, integration and vectors. I will be covering them in detail but in the coming lectures. Today we are going to start with the very basics. Okay, so the first topic which we are going to study is functions. This is functions. So before starting functions, just let me list the important topics which we need to understand physics. So first is functions. Second is straight line. Third is quadratic equations. Fourth is trigonometry. Now these all topics you have already covered in your smaller classes, right? But I will teach you each of them from the very beginning. So you don't have to worry. If you know, very good. If you don't know, just pay attention. Now fifth topic, these are the topics which will be new for you. First is differentiation. Second is integration. And last one is vectors. So the starting lectures will be very important for you because that will be the base of a house. Okay, so let's suppose if your base is very good, you will be good at that subject. Okay, if your base is not very strong, that building can collapse anytime. So let's start with the first topic, functions. So what do I mean by functions? So let's start with an example. Okay, so like summer has went by, right? And the favorite drink which I used to love very much is, and I love very much, is mango shake, right? We all love mango shake. So now what is the process to make a mango shake? I will buy some mangoes from the market, right? I will wash them and then I'll take a juicer, right, or a mixer, and in that juicer I'll put my mangoes, I'll cut the mangoes, peel the mangoes, and I'll cut it inside the juicer. I'll turn on the juicer, and what I'll get a mango juice. Very simple. So similarly, let's make a diagram. Just 1 minute. So let's say I have a machine, a juicer machine. Okay, this is a juicer, and I want to drink mango juice. So I'll insert mango inside, and what I'll get output as mango juice. Right? Now, let's suppose I want to drink apple juice or orange juice. So what I'll do? If I want to drink an orange juice, I'll insert orange. Right? And I'll get an orange juice. Let's suppose I want to drink apple juice. So if I want to drink an apple juice, I will give an input of apple. Right? So I'll get an apple juice. So now what I'm trying to say that, what is this? This is what I'm putting inside my machine. So can I say that this is my input? Right? This is my input basically. Right? And what I'm getting outside is my output. This is my output. And this is my machine. This is my machine. So now in this machine, if I want to write in terms of mathematics, so I can say this is my input, this is my output, and this machine I'm representing by F. So if I want to write in terms of maths, I can say that in my machine, if I put an input, I will get an output. Right? So this is what a function means. That in my function, if I put some input, I will get an output. And my output will depend on my input. What do I mean by that? I mean that if I put mango, I'll get a mango juice. I cannot get an orange juice. Right? If I put an orange, I'll get an orange juice. I will not get a mango or an apple juice. So let's read the definition now. So function is a rule of relationship between two variables. So it is a rule, okay, of relationship between two variables. So what are the two variables? Input variable and output variable. So this is known as input variable, and this is known as my output variable. Right? In which one is assumed to be dependent and other is independent. So these two are very important terms. So what do I mean by independent and dependent? So now let's see. I want to drink an orange juice, right? And you might want to drink a mango juice. So that depends on me, right? But I'm not restricted, right? You're also not restricted that if I'm drinking a mango juice, you also have to drink a mango juice. So what I put inside this machine will not depend on anything, right? You can choose any fruit of your choice, right? Or any vegetable. Let's suppose I want to drink a cucumber juice. So this input will not depend on anything. So my input is independent. It is my independent variable. This is my independent variable. Okay, so input is always independent. Now, let's suppose if I have fixed that, okay, I will take a mango. Now, once I put this mango inside this machine, I am 100% sure that I will get a mango juice, right? If I put a mango inside, I will only get mango juice. I cannot get orange or apple juice. Or, so what I am trying to say here? I am trying to say that once your input is fixed, your output will depend on your input. Okay, so this output is depending on my inputs. So this is my dependent variable. Right? So now let's read the definition once again. So function is a rule of relationship between two variables, my input variable and my output variable. Here fruit and juice assumed to be dependent and the other independent variable. So now I hope it is clear to you that what a function is, and you can always come back to this analogy, okay, and understand function in a very easy way, right? So let's move on to some questions. So let's suppose I have this question, and in this question it is given that the volume V of a solid sphere of radius r is given as a function of Vr is equal to 4 upon 3 pi r cube. So what he is trying to say that Vr is equal to 4 upon 3 pi r cube. Now what is this? Okay, what he is trying to say here? So now in this function V is my machine, right? V is my machine. In this machine I am giving input as R, right? And what do I get output? I get output as the volume of my sphere, volume of my solid sphere. So let's suppose in this question, this if I put R, value of R, for different values of R, I will get different volume of the sphere. So let's suppose if I take a sphere of radius 1 meters, so it will give me the volume of this sphere, right? Now if I take a sphere of radius 2 meters, so what will it give me? It will give me the volume of a sphere of radius 2 meters. So as I keep changing my input, that is my radius, right, the output, that is my volume, will keep on changing. Okay, so if we go back to my analogy, what was the analogy? That in a machine I was giving some input and I'll get some output. Here is my machine. In this machine, this is my machine, and in this machine I am giving R as my input, right, radius as my input, and for different radius I'll get different volumes. So now what he's asking, that the volume of a ball of radius 3 meters. So now what he's trying to say, he's trying to say that what should be the volume when the radius is 3 meters. Okay, so this is very easy question. Okay, you would have done this 100 times, but what I am trying to teach you is what function means. Okay, so pay attention that he's saying that at r equals to 3, what is the volume? So now what I am doing, I am fixing my input, okay, and that input is r equals to 3, r equals to 3. So this I am putting as r equals to 3. So what is this similar to? It is similar to picking a fruit. Okay, let's suppose I have picked a mango fruit. So now since my fruit is fixed, the output will be fixed, that is mango juice. Similarly, my input radius is fixed, right? The input which I am giving, that is r equals to 3, is fixed. So the volume will be fixed. So let's see what the volume comes out to be. So 4 upon 3 pi into 3 cube, right? So what I'll get? I'll get 4 pi into 3 square, that is 9 and 4, right? So 4 9s are 36 pi. So 36 pi meter cube. So this is my answer. So for r equals to 3 input, 36 pi is my output, correct? So now I think you know what a function is. Okay, there can be many different kind of functions. Okay, so let's do one more question. Suppose that the function f is defined for all real numbers. So what do I mean by real numbers? Real numbers is that, so this is a real line, okay, real number line. It starts from 0, it goes to infinity, and it can also go to minus infinity. So from minus infinity to infinity, any number lying on this line is a real number. It can be a fraction, rational number, irrational number, decimal, real whole number, any number is a real number. Okay, now, so that suppose is defined for all real numbers are by the formula. The formula function is given to me, fr is given to me as 2 into r minus 1 plus 3. This is the function given to me. So what he's trying to say? He's trying to say that evaluate f at the input values. So he wants to find the value of f for input 0, for input 2, for an input x plus 2, an input x plus 2, right? So the input value x plus 2 and f of 2. So we'll come back to this, okay, after I teach you one more topic, we'll come back to this, okay. So now, so f of 0, f of 2 and f of x plus 2, I want to find all these values. So what I'll do, this is my input r. So let's put input r as 0. So what do I get? I'll get 2 into 0 minus 1. Look here, if I put r equals to 0, I can get this value, right? So I'm putting r equals to 0. So 2 into 0 minus 1 plus 3, plus 3. So I'll get 2 into minus 1 minus 2 plus 3, that is 1, right? Now here f of 2, to find f of 2, I'll put r equals to 2. So I'll get 2 into 2 minus 1 plus 3, that is 2 into 1 plus 3, that will give me 5. And lastly, I am trying to find f of x plus 2. Now x plus 2, so what he is trying to say? That put the value of r equals to x plus 2. So if I put r equals to x plus 2, I'll get 2 into r is x plus 2 minus 1 plus 3 equals 2. So 2 into x plus 1 plus 3. So this will give me 2x plus 5. Right? So now it is the same exercise as the last question. For different values of input, I am getting different values of output. So now one important thing I want to say is that when I say f is a function of r, when I say f is a function of r, I mean that my input is r, okay. When I write in last question also, volume was a function of radius. Volume is a function of radius, means if I change my radius, my volume will change, right? Yes or no? If I change the height, will my volume change? If I change my height, let's suppose if I am standing on this ladder and I bring a ladder and I change my height, will the volume of this sphere change? No, it is not a function of my height, it is a function of the radius, right? Now let's suppose if I take the ball, okay, if I take this ball and I throw it, okay, I throw it, okay, so now will the volume change? No, because my volume is a function of radius. It will only change when the radius changes, otherwise my volume won't change, okay. So now let's jump on to the next topic. The next topic is function of a function. So what do I mean by a function of a function? So let's go back to the first analogy. Was my machine, and as an input I gave a fruit, right? I gave input as a fruit. So what I'll get? I'll get some juice, right? It will depend on the fruit. That, let's say I have a fruit. So as an output, I'll get some juice. Now, I want to freeze that juice in the ice cube tray, okay, so that I can get an ice cream of that juice. Okay, I can do that. So if I have to freeze that, so what I'll get? Let's say I'll get some ice cream. I'll get an ice cream of that juice. So I'll get an ice cream. So let's say my fruit here is mango, and I'll get a mango juice, and my output will be mango ice cream. Right? So my output is mango ice cream. Now, so what are the different machine we will use here? The first machine is juicer, and my second machine will be fridge. So now what I am doing? Here I am first using this machine, right? So the input 1. So this will be my input 1. And through that input 1, I'll get output 1, right? Output 1. This output 1 will act as an input to my machine 2, that is my fridge. And when I put this input here, I'll get an output 2. So can I say this is my final output? Right? So now what I am doing, I am putting the input here. I'll get some output. This output will act as an input for my machine 2 or my function 2. And when this machine takes this input, it will give me some output again, and that is my final output. So for this machine took one input, and machine gave me one final output, right? So I can say this is one combined machine. So this is what I mean by a function of a function. Function of a function. So let's write an example. Let's look this by an example. So let's say first function fx. So this is a function of x is equal to 2x plus 3. Okay, and let's say some other function gx is equal to root x. Okay, so now let's say they ask me that find f of g of x. So now if they say find f of g of x, so now let's look at this closely. So now this gx is acting as an input for f of x. So f input. So for my function f, what is my input? Gx, right? And can I find gx? Yes, gx is given to me. So gx is root x. So I can say that f of gx is basically root x. It is given to me, right? Now f of root x, can I find f of root x? Yes, if I put x equals to root x. So if I put x equals to root x, can I get f of root x? Yes, so I'll get, so what is f of root? This will become 2 into root x plus 3. So this is basically f of g of x. So here what we did, basically first I find the inside value, this. So basically first this machine, this was my machine 1, this was my machine 1 and this is my machine 2. So what is this machine 1? This machine 1 is g of x. In this it takes x as an input and output will be g of x, right? It takes x as an input and the output will be g of x. This is g of x, right? So this is basically g of x, that is root x. So as an input I gave x, output is root x, right? This is my function gx. Okay, now this output will go as an input for my machine 2, right? So what is a machine 2? My machine 2 is f of x, right? So in this machine f, this takes input as gx, that is basically root x. So in this f of x, I'll put input as root x. So as I put input root x, I'll get 2 root x plus 3. So that is my output. So now if I give you one more question, that find g of f of x. So what will be g of f of x? Just pause the video and try to solve it by yourself. Okay, so g of root of x, f of x. So now what is the input? Input will be x. So my first machine will be now f of x. So what I'll get? I'll get 2x plus 3. So now I'll get output 1 as 2x plus 3 and that will be given to as an input to my machine 2, that is gx. So the final result will be root of 2x plus 3. Okay, so let's just try to work it out. It is very easy. So now you know what a function of a function is, right? So let's do this question now. So the function fx is defined as x square plus 3. So he wants to find f of 0, f of 1, f of 0, f of 1, f of x square. So f of 0, f of 1, f of x square, f of x plus 1 and finally f of 1. So I think you can work them out very easily. So put x equals to 0. So I'll get 0 square plus 3, that is 3. Here if I try to find f of 1, I'll put x equals to 1. So I'll get 1 square plus 3, that is 4. Right? If I put x as x square, so I'll get x square whole raised to square. Because see now, look very closely. Instead of x, I'll substitute x square. Instead of x, I'll substitute x square. So x square raised to square plus 3. So this will give me x raised to 4 plus 3. Now f of x plus 1. So instead of x, I'll put x plus 1. So x plus 1 whole square plus 3. So these were very easy. Now let's just try to find this out. So this is basically function of a function. So now can I say first I should calculate this, right? So if I calculate this, so let's calculate f of 1. So see, f of 1 you have already calculated here, that is 4. So can I say this value is 4? So basically this is f of 4. So I want to find f of 4, right? And to find f of 4, I'll just substitute x equals to 4. So f of 4 is equal to 4 square plus 3, that is 16 plus 3 is equal to 19. So f of 1 is equal to 19. I hope this is clear to you, that how you can solve function of a function. Okay, so let's move forward now. So now we'll come to the next topic, that is domain and range. Okay, so what do I mean by domain and what do I mean by range? So let's go back to that example analogy which we were talking about. So in this analogy, what is the input I can give? What are the possible input values I can give, right? So let's suppose if I have a juicer, if I have this juicer, and this juicer, what can I give? I can give fruits, right? I can give vegetables, but can I give stones? Can I put clothes inside a juicer? No, right? So I can give input fruits and vegetables. So these are the only possible values or items I can give to my machine. So what is the domain? Domain is all the possible values which can be given as an input to my machine. I'll repeat. What is a domain? Domain is set of all possible values which I can give as my input. Set means a collection, okay? Collection of all the possible values which I can give as an input to my machine. So now what is range? If I put fruits or vegetables inside my juicer, what do I expect as my output? I will expect juice, right? I cannot expect stones, clothes, right? So what is my range? A set, or basically a collection of all the possible output values which I can get from my machine is my range. So definitions are, I think the definitions are clear to you. Okay, so now let's look at this definition. So what is domain? Domain of a function is set of all possible input values. Okay, so set is basically a collection. The domain of a function is a set of all possible input values that a function can expect. Okay, so it can take without causing any issues, such as division by 0 or taking the square root of a negative number. So now what is this? What he is trying to say here? That let's suppose I have a function f of x is equal to 2 by x. Now in this function, if I put x equals to 1, what I'll get output as? For f of 1, I'll get output as 2 upon 1, that is 2. If I put my input as 2, I'll get 2 upon 2 is equal to 1. If I put input as minus 10, so I'll get 2 upon minus 10 equals to minus 1 upon 5. So no problem I can see here. But let's suppose if I put my input as f of 0, I put x equals to 0 as my input. So what do I get? I get 2 upon 0. Now what is 2 upon 0? 2 upon 0 is not defined, right? I cannot divide any number by 0. So I have an issue here. So now what is the issue here? The issue here is that I cannot give this function an input of x equals to 0, right? For any other value other than x equals to 0, I will get my output, okay, which does not violate any rules, okay, which is mathematically correct. But for x equals to 0, I will get undefined number, undefined. So I can say that the range for this function, so the range for this function is, so the range for this function is, sorry, domain, because we are talking about the input value. So the domain of the function is any number r. Okay, r means real numbers. Any number man r, that is real numbers, and you subtract 0 from it because it is not applicable for x equals to 0. Or I can say any real number other than 0. Correct. So this is my range for the function. Now, or taking the square root of a negative number. So let's say if I have this, I have a another function which of f of x is equal to root of x. Right? I have f of x is basically root of x. Now, as an input, what are the possible values I can give? So let's check. Can I give f of 0? Yes. For f of 0, I'll get root 0, basically that is 0. Can I give f of 1? Yes, I can give f of 1, I'll get root of 1 is equal to 1. Can I give f of 5 by 2? Yes, I can give 5 by 2, I'll get root of 5 by 2. That is some positive value. But let's say I want to give f of minus 1 as my input. I want to give minus 1 as my input. So what is the value I'll get? Root of minus 1. So now root of minus 1. We again have a problem here. What is the problem? We know that root of minus 1 is not defined, right? So root of minus 1, negative inside a root is not possible. Okay. So since negative inside a root is not possible, what we will say? That it cannot take input as minus 1. Let's talk about minus 2. F of minus 2. Root of minus 2. So what is root of minus 2? It will be root of 2 into root of minus 1. So now is this possible? Root 2 is 1.414. But what about root minus 1? That is again not possible, right? So now minus 2 is also not possible. So now any negative value is not defined. Okay, I cannot give that as my input. So here, what is the range? The range, I can write range as all possible values. All ranges basically all possible values. And what are the all possible values which I can get? They are x greater than equal to 0, right? X greater than equal to 0. All numbers which are greater than equal to 0 are only possible. So that is my range of this function. Okay, so we can encounter many other such scenarios. These are only two of the scenarios, okay, or the problems or the issues which we are facing. And these are the two most common scenarios which we face. There are many other scenarios which we can get. As we go forward, we'll come across them. Okay, so let's move forward. So I hope now domain is clear to you. So now what is range? All the possible output values. Range of a function is the set of all possible output values. Okay, all possible output values that the function can produce when you plug into the values from the domain. So now what I'll do, I'll take values from my domain. Okay, set of all input possible values. Now from the input values, I'll put that inside my function and I'll get some output values. So all the possible output values are my domain. So are my range, sorry, not domain, range, right? So if I put fruits inside my machine, I am sure that I'll get some fruit juice. right? I'll not get petrol or diesel or kerosene, correct, or some oil. So here range is set of all possible output values. So let's look at this question. So f of, let's say I have this machine, f of x is equal to root x. So now as we looked in the last question, what are the possible values of input? X greater than equal to 0. This is my domain. So now what are the possible values I can get? So let's say I put the lowest number, that is f of 0, I'll get 0. I'll put f of 1, what I'll get root 1 is equal to 1. I'll put f of root 2, I'll get f of 2. If I put f of 2, x equals to 2, what do I get? For x equals to 2, I'll get root of 2, that is 1.414. Okay, now let's suppose if I put root 49, x equals to 49, so what do I get? Root 49, that is 7. So now I can put anything here, right? If I put f is equal to 100, or let's say I put this 10,000, what do I get? Root 10,000 equals to 100. So now what can we see here? We can see that for my possible input values, okay, from my domain, whatever values I am putting, I am getting all positive values, okay, I am getting decimals, I am getting whole numbers, okay, but I am not getting a negative value, right? I am also getting 0, but can I get a value which is less than 0? Can I get a negative value? No. So what is my domain? So domain is basically set of all, range is basically set of all possible output values. So my range will be equal to all values x, okay, f of x is greater than 0. X was greater than 0, but now output is f of x and all these values are greater than 0. So my domain is also x greater than equal to 0. So now I hope you are clear what domain and range is. So we'll continue with domain and range in the coming classes. Okay, we'll continue with domain and range in the upcoming classes. Okay, wherever I talk about a function, I will tell you that what are the possible values, input values. Okay, so now let's move on to some different kind of functions. So now what is this logarithmic functions? So now what is this? This is a special kind of function which we will be needing, right? So what is log function? A log function, also known as log function, okay, a short name for this is log, is the power to which a number must be raised in order to get some other number. Okay, so what is this basically? So we write this as log, so number x base 10, okay, or any base, it can be, this base can be anything. So this is my base. So let's write this as my base. And I'll get output as y. Right? So if I want to solve this, what can I write? I will just cross multiply this base here, and this y will go into the power of my base. So I'll get x equals to base raised to y. So now let's read this again. The log is the power to which a number must be raised in order to get some other number. Okay, this is my base to which I have raised some value to get some other number. Right? Now the base 10 log of a 100. So base, so what is base? Base is 10 of 100. So what is 100? 100 is my x here. And what is y? Y is 2. This is my y. So how do you get this? We'll learn. Okay, we learn this, that how do you get this? So this is a very important formula. These two formulas are very important for you. How to write from this to this? I already told you that you take this base here and you raise that to y, right? So now let's do one question. So now before doing the question, these are some, so let's say, so log, if I want to find log, as in this question, log 100 base 10 equals to what? I want to find the value. Let's say this is y, right? So what can I say? I can say 100 is equal to 10 and this y will go in top, right? So I can write this as 10 square is equal to 10 raised to y. So what do I get? If I compare the powers, so I'll get 2 equals to y. So y equals to 2. So this is how you get y equals to 2, right? I hope this is clear. Now let's say if I write log e raised to 3. So what is the value of log e raised to 3 is? This is basically, let's say, y. So I can write 3 equals to e raised to y, right? Now what is e? Okay, e is some number, like pi is a number, that is 3.14. E is also a number, 2.7 something something. Okay, e is also a number, right? So e is also a number. So let's say what is e? E is also a number. So now how to find this value, right? We don't know what this value will be, right? It was very easier to find this. So to find this, we use log tables. Log tables. Okay. So we don't require this. Okay. We can easily learn how to use log tables. Okay. But now, right now, we don't require this. Okay. So now there are some rules. There are some rules which we follow so that our calculations become easy. So let's look at the rules one by one. So what is the first rule? First rule is log of m into n. So if I have some function as log of m into n, okay, your base is 10. If see, nothing is written here, okay, this base can be anything, okay, this base can be anything, but this base cannot be 0. They cannot be 0 or less than 0. It can only be base. So for the condition of my base, for base is always greater than equal to 0, right? So I can also prove that, if you want, that why base cannot be. So let's say I have this base, right? And if I take this base as some negative number, okay, so let's say I get x is some negative number, so let's say minus some number, let's say minus 3 raised to y, right? Now minus 3 raised to y. So if I have x as some number, so let's take some example only. This will be easy if you understand by an example. So let's say I want to find log 2 base minus 10. Okay, I want to find this number, log 2 base minus 10. Let's say this is some y. So if I try to solve this, what do I get? I'll get 2 equals to minus 10 raised to y, right? 2 into minus 10 raised to y. Now what do I get from here? Look here very closely. So I'll get 2. Now what is the possible values of y for which I'll get minus 10, a positive number, right? So you cannot get a 2, right? Minus 10 raised to, if I do 3, I'll get a negative number. So LHS is negative, RHS is positive. Okay, so here we have some issues. So if we take a even number, then we can get it correct, right? But for all values it is not possible. So that's why we can only take base as positive. No, sorry, we can take base as negative also. Base can be negative, but this output, sorry, I'm really sorry. Just let me correct myself. This base can be anything. I am talking about the domain, sorry. The domain that is x is always greater than 0. Now y greater than equal to 0. So let's say if I write log x raised to 10 is equal to y, right? So x is equal to 10 raised to y, right? Now let's say if I write 10 raised to y, right? Now y can be anything, right? Y can be anything. Now x, let's talk about x. So let's say this y is some number. Okay, now if I take y as minus 2, let's say y I take some positive number plus 2 and y I take some negative number minus 2. So if I take y as some positive number, I'll get 10 raised to 2, that is 100, right? Some positive value. But if I take y as some negative number, so I'll get 10 raised to minus 2 is equal to 1 upon 100, right? So even if I take y as positive and y is negative, I'll get a positive value only, that is 0.01. I can never get a negative value of x. So my domain of a log function is always x greater than 0. Okay. I apologize for the comment I made on the base. Base can be anything. Okay, I just mixed that up. So now domain. So let's come back to the rules. So what is the rules? Log m into n is log m plus log n, right? Log m plus log n. So if I have something as log 6, so I can write log 3 into 2. So I can write it as log of 3 plus log 2. Now you can ask me that, sir, where is the base? So if nothing is written here, you take base as 10. Similarly, if log m by n is given to you, so log 3 by 2 is given to you. So what can I write? I can write log 3 minus log 2. And if log m raised to n is given to you, so log, let's say log 10 square is given to you. So what you can do? You can take the power forward. So you'll get 2 log 10. And if log a by b is given to, so what I'm doing, I'm changing the base. Okay, this is known as base changing. So what I am doing, I am changing the base to c. I am changing the base to c. So let's say if log 2 by 3 is given to you, log 2 base 3 is given to you, and I want to change the base to 10. So I can write log 2 base 10 and log 3 base 10. Right? Why we do this? We do this so that we can solve a question very easily. Okay, so these are some rules, and I will give you some practice sheets. Okay, you will find that practice sheet in the link in the bio, so that will be very helpful for you if you solve questions. Okay, so let's move forward. So we have some questions to solve, so let's solve these questions. I have log 10 into 5000. So what can I write this as? I can write log 1000, 10,000 base 2, right? So what do I get? I get log 10,000 minus log 2, right? And log 2 and log 10,000. So I can solve the values for log 10,000 and log 2. So here I can get log 10 raised to 4 minus log 2, right? Now what is value of, so I'll get here 4 log 10 base 10. So which property I am using? I am using this property. So which property I used? I've used this property and I've used this property, right? So this property I've used minus log 2. So what do I get? So what is log 10 base 10? So what is log 10 base 10? So let's find log 10 base 10. So log 10 base 10 is equal to, let's say, y. So 10 equals to 10 raised to y. So y will be equal to 1, right? So log 10 base 10 is 1. So 4 into 1 minus, what is log 2? So log 2, as I said, you can find using a log table and the value comes out to be 0.3. Okay, it's an approximate value. So what do I get? 4 minus 0.3 will give me 3.7. Okay, so log 2, log 3, log 5, log 7, log 9, these are some values which you have to remember. Okay, so now, so this is a question for you. Just try to just copy this out and try to solve it by yourself. Pause the video and solve this by yourself. Log 10 base to 25, right? So log 25. So what can I write? I can write log of 5 square upon 10. So I can get 2 log 5 base 10. Now try to find what is log 5. Okay, try by it yourself. So my last topic is the exponential function. Okay, I encourage you to solve it by yourself. Okay, go and look up at the internet that what is the value of log 5 base 10. Okay, if I give you some exercise, please do that so that it will be very helpful for you. Will learn something. Okay, and looking up at the internet is a very good thing. Okay, you should have that skill so that you should not be dependent on others to teach you. Okay, if you can have that courage to look up at the internet, okay, you don't know something, go up to the internet and look. Okay, this should be the answer of this. Okay, you don't know anything, go up to the internet, everything is available there. Okay, so now just try to find this out, what should be the answer. Now my last topic is the exponential function. So what do I mean by the exponential function? So the function ex is known as the exponential function as opposed to any other exponential function, as is extremely important in all branches of science. So now as I write, so we know what is 2 raised to x. So let's say I have a function fx is something as 2 raised to x, right? So now if I substitute that 2 by some number, that is 2.72. Okay, so let's say if I write f of x is equal to 2.72 raised to x. So this 2 is basically my exponential. So I can write e raised to x. So 2.7 is a very important number. Okay, so we call this function as exponential function. There is nothing very different about this. It is just that what is e is 2.72. You just have to remember this. So where it is used? It is used in radioactive materials undergo exponential decay. Okay, there are some radioactive materials, right? What do you mean by radioactive materials? Materials which emit energy, okay, radioactive energy, right? So like uranium, Rhenium is a radioactive substance, right? You cannot go close to it. That is very harmful for our body. So in that decay means it is basically breaking down. Okay, that breaking down, it follows exponential function. The world human population is increasing exponentially. So as we go, okay, from 10 years from now, the population which we have now will be double, more than the double. Okay, it is growing at a very fast rate, so we call it an exponential growth. Chemical reactions depend exponentially upon the temperature. Okay, so exponential functions are very useful. So now, what does e raised to x look like? So let's try to find out. So if I have x equals to 0, right? So if I have x equals to 0, so if I want to draw the graph, let's say e raised to y equals to e raised to x, or 2.7 raised to x. So let's draw the graph. Okay, for some x, what is the y? So for x equals to 0, 2.7 raised to 0 is 1, right? If I put x equals to 1, I will get 2.7 raised to 1 is 2.7. If I put x equals to 2, I will get 2.7 raised to 2, right? And that value is equal to 7.39. If I put x equals to 3, I will get 2.7 raised to 3. So that value is equal to 20.1. If I put x equals to 4, what do I get? 2.7 raised to 4, and that value is equal to 54.6. Right? So what I am trying to say here, that if I try to draw the graph, so here I have 0, I have 1, I have 2, I have 3, I have 4, I have 5, and so on. Here I have, let's say I have 1, let's say I will have some 5 here. So let's try to make the graph 5, 10, 15, 20, 25. Okay, so now for x0, y is 1. So for x0, what is the value of y? Y is 1. So let's say y will be 1 somewhere here. So x0, y is 1. Now for x1, y is equal to 2.7. So x1, y is something 2.7. So here it will lie here, right? Because this is 5, 2.5 will lie somewhere here in the middle, right? So this will be somewhere here. So let's make it there. Okay, I mark this point. Now for x equals to 2, what is the value of y? 7.4. So this is 10, 7.4 will somewhere lie here. So 2 and 7.4, so it will lie here, right? Now x equals to 3, what is the value of y? 20.1. So x equals to 3, the value of y is 20.1. So it will come here, right? For 3, the value is 20.1, right? So now 4 is, it is 54, it is going out. So let's just try to make the, right? It is a bit crooked, just give me 1 minute. So these are my points basically. I want to connect these points, right? I want to connect this point, right? So what can I see? It is growing at an exponential rate. And let's talk about the negative numbers. Let's talk about the negative numbers. So if I put x equals to -1, so if I put x equals to -1, what do I get? 2.7 raised to -1, that is 1 upon 2.7, that is less than 1, right? Now if I put -2, what do I get? 2.7 raised to -2, that is 1 upon 2.7 whole square, right? So 1 upon 7.39. So this is less than this also. So if I try to draw an exponential graph, right, all the values are less than 1, okay, this is 1, so it will be like this, okay, so it will go down to 0. Okay, it will never go to 0. Why? Because let's say if I take a very large number, if I take x as equal to 10,000, x equals to 10,000. So what is e raised to minus x? E raised to minus 10,000. So that will become 2.7 raised to minus 10,000, right? So I'll get 1 upon 2.7 raised to 10,000, and this number will be nearly equal to 0. So it is not 0, right? It will never be 0, right? So it is going like this. It will never touch the x-axis, okay? And here it will go to infinity, right? So this is the exponential graph or an exponential growth, right? Now, what you have to do? You have to draw graph of e raised to minus x. Okay, I have drawn the graph for y equals to e raised to x. Okay, this graph is for y equals e raised to x. What is your homework? Your homework is to find the graph for e raised to minus x, right? Just try to make it by yourself. So this is what exponential function means. So today we covered about log functions and exponential functions. So this is up for today. Okay, I will be giving you some homework questions, and you will find them in the description box. Okay, in the bio below. So please check them out and try to solve the questions. From tomorrow, I will give you a scanner directly in the PPT, so you can scan that and solve questions. But for today, just go into the description box and look for the homework sheet PDF. Okay, so thank you. I hope you enjoyed the first lecture on functions. Okay, and tomorrow we'll be studying about straight lines. I think about straight lines. So please join. Thank you very much.